All right, the third type of proof by induction that we're going to look at here now is proof of inequalities. Now, for the purposes of this, I'm going to take a question from last year's Leaving Cert paper. And the question we're going to look at is proving 3 to the power of n is greater than or equal to 4n plus 1 for n is greater than or equal to 2. Now, in the inequalities proofs, this is where we start to see restrictions. So it's not simply just n is an element of natural numbers. We have an additional restriction that n has to be greater than or equal to 2. So a lot of the inequalities will have this, and you have to be careful. When you're doing step 1, you're not going to start off with n equals 1. In this case, you're going to start off with n equals 2. So step 1 is we prove true for the first natural number. So prove true for n equals 2. The reason it's 2, again, is due to our restriction here. So we substitute 2 anywhere we see our n here. So we have 3 squared greater than 4 by 2 plus 1. On the left-hand side, we have 3 squared, which is 9. On the right-hand side, 4 2s are 8 plus 1 is 9. 9 is greater than or equal to 9, so therefore it is true for n equals 2. So that's step 1. Step 2 remains the same. We assume true for n equals k, and that means that we assume that 3 to the power k is greater than or equal to 4k plus 1. Now for step 3, here is where the difficulty comes in. For inequalities are probably the most difficult type of proof by induction because there's a lot of manipulation required. So what we do for proof by induction, so again, step 3 is we want to prove true for n equals k plus 1. And what we want to prove is that 3 to the power of k plus 1 is greater than, replacing the k with a k plus 1 there, so 4 times by k plus 1 is 4k plus 4, and then we have plus 1 at the end, so 4k plus 5. So this here is what we want to prove. So when we're looking at inequalities, we know that step 2 is definitely true. We've assumed that to be true. So that should be our starting point. I'm just going to rub off step 1 so that I have some room to work up here. And I'm going to leave this here at the bottom. This is what we want to prove. So starting off with step 2, we know that 3 to the power of k is definitely greater than 4k plus 1. So we want to create a middle ground in between these two expressions here that we can prove. So the first thing we do is we work on the left-hand side. We want our left-hand side to be 3 to the power of k plus 1. Using our rules of indices, if we want to add 1 to this power here, we have to multiply that by 3. So 3 times by 3 to the power of k gives us 3 to the power of k plus 1. Now, if we're doing that to the left-hand side, we also need to do it to the right-hand side. So that'll be 3 times by 4k plus 1, which gives us 3 to the power of k plus 1 is greater than or equal to 12k plus 3. So now we've created our middle ground. So we have the left-hand side of our inequality. This is our middle ground. We now want to prove that this middle ground is greater than or equal to our right-hand side. So we add on a little bit on here at the end. So we're adding on our right-hand side now over here. And we want to concentrate on this expression here now. So 12k plus 3 greater than or equal to 4k plus 5. What we can do here is bring all the k's to one side. So 12k minus 4k is 8k. And 5 minus 3 is 2. We know that this has to be true because k has a minimum value of 2. So 8 times by 2 is greater than or equal to 2. Therefore, that is true. And it's true for all k is greater than or equal to 2. So because we have proved that 3 to the power k plus 1 is greater than 12k plus 3, 12k plus 3 is greater than 4k plus 5, that must mean that 3 to the power k plus 1 has to be greater than or equal to 4k plus 5, which is what we wanted to prove. And then we do our conclusion as normal. So we say that therefore it is true for n equals k plus 1, provided true for n equals k, and true for all n is an element of the natural numbers and n is greater than or equal to 2. All right, so your conclusion just has to mention that you have tested all of your possibilities. So your step 1, your step 2, and step 3. So again, use your step 2, manipulate the left-hand side to make it sure that it looks like the left-hand side of step 3. In doing that, you will have manipulated the right-hand side of step 2. And then you work with the right-hand side of step 2 and the right-hand side of step 3 to make sure that your middle ground is greater than your right-hand side. Once you've proved that, then you can say that it is true for n equals k plus 1. A lot of the inequality, so this is kind of a standard kind of inequality one that comes up. A lot of them will require some more manipulation. Look out for proving that square numbers are greater than 0 and things like that. So as you go through the questions in the assignment, you'll get a feel for that. But there are plenty of examples in the exam papers that you can have a go at.